Good afternoon, everyone. Hope you had an amazing first day back. Today we're going to be talking about graphing quadratic functions. So first, the parent function, also called the mother function. The quadratic parent function is x squared. Pretty simple enough, right? Very straightforward. Now a couple of things if you want to make your xy chart here. -3, -2, -1, 0, 1, 2, and 3. Plug those in, you get 9, 4, 1, 0, 1, 4, and 9. Come over here and plot those points. 0, 0, 1, 1, 2, 4, 3, 9, -1, 1, -2, 4, -3, 9. And make your best effort at a perfect parabola. I will say it will help you drastically to memorize that graph very quickly. Just memorize it. All right? It's going to help you out a lot in the later on part. Your domain is left to right. Obviously, it's all real numbers. Range is 0 to infinity. Actually touching 0, not touching infinity. Characteristics of it. First off, it's symmetrical across y, so it's going to be even. It's an even function. Remember, even means it's symmetrical across the y-axis. It increases from 0 to infinity. Decreases from -infinity to 0. What else? You have a vertex, which happens at 0, 0. And you have an axis of symmetry, which means it is symmetrical across the y-axis, which happens to be x equals 0. Now, with all this stuff, this is going to go back to the very first unit that we did this year. I'm talking like beginning back in August. This is talking about axis of symmetries, transformations. So I'm going to review it a little bit before we get too heavy in there. A little bit of information here. It says graph the following transformations of f of x equals x squared and check on your calculator. I'm just going to graph them. You can check on them later. So transformations, remember if it's inside of the parentheses, it applies to x, and we always do the opposite. So x minus 3 means we're going right 3. And -4 out here means down 4. So I'm going to take the parent function and move it right 3 and down 4. My first point was 0, 0. So I'm going to go right 1, 2, 3, down 1, 2, 3, 4. Now when I said memorize this graph, what I'm talking about memorizing is the pattern here. If you memorize this pattern, it becomes really easy to repeat over time. It was up 1 over 1, or you could do over 1 up 1. So 1 and 1, and then up 3 over 1, up 5 over 1, 1 over 1, 1, 2, 3 over 1, 1, 2, 3, 4, 5 over 1, right? What I'm doing here is just kind of measuring off these steps. So we've got 1, 1, 3, 1, 5, 1. And that just makes it really easy to come down here. I'm not modifying anything outside, so I can just go 1, 1, 1, 2, 3, 1, 1, 2, 3, 4, 5, 1. And it makes it really quick. 1, 2, 3, 1, 1, 2, 3, 4, 5, 1. To go through and do your parabola. Now you could do these one point at a time. It makes absolutely no difference. If you wanted to start with your pencil at the point 1, 1, down here, 1, 1, and then go right 3 and down 4. You end up on the same point. So if you don't memorize the 1, 1, 3, 1, 5, 1, then you can memorize it that way and just apply it to each point. That's fine. All right, so remember when there's something outside of the parentheses, that's a vertical stretch or shrink. Now this one is stretching by 2. So that's a vertical stretch of 2. Now what that means is instead of going up here, instead of going up 1 over 1, I'm going to go up 2 over 1. And then up 6 over 1 instead of 3. See, it just makes them a lot easier. And then plus 2, we're going to go left 2 as well. So starting off, I'm left 2, so from 0, 0, go left 1, 2. And my original was up 1 over 1, up 3 over 1. So I'm going to go, since I'm stretching 2, I'm going to go up 2 over 1. Up 1, 2, 3 times 2 is 4, 5, 6. Oops, over 1. I forgot my over 1 there. And once you get one side, just come over and repeat it on the other side. See how quick these are going? These do not have to be the bane of your existence. They really don't. They're pretty simple. They're very straightforward. All you have to do is apply all of the transformations that you see. So this one's got quite a bit going on here, a little bit more difficult of an example. First thing that I see here, I see the 1/2 being applied to this. That's a horizontal stretch since it's on the inside of the parentheses. See how it's inside of the x plus 1? It's inside of the parentheses. So this is going to be a horizontal stretch by 2, right? Horizontal stretch, and I know that because it's inside of the square. So horizontal stretch of 2. So I'm stretching it because I always do the opposite of what's in the parentheses. And then I'm going left 1 and up 2. Left 1, up 2. So there's a difference between a horizontal stretch, which is inside of the square, and a vertical stretch or shrink, which is outside of the square. If it's inside, it's horizontal. If it's outside, it's vertical. So I'm going to be stretching my x's by 2. So first let's start off by going to 0, 0, left 1, up 2.
Attention students, bus 430 is ready.
Left 1, up 2. And in case you're wondering, bus 418 is going to be taking over for bus 30, just in case you were curious. Left 1, up 2, right? And then a horizontal stretch by 2. Horizontal stretch by 2. So remember, it was up 1 over 1. But now instead of going over 1, I'm going to go over 2. Right? And then it was up 3 over 1, so I'm going to go over 2. And then it was up 5, 1, 2, 3, 4, 5 over 1, so I'm going to go over 2. One, 2, 3, 1, 2. 1, 2, 3, 4, 5, 1, 2. All applied at the same time. So if you notice, there's a process to this. Start with your vertex, because that's the easiest one to find. It just goes left or right, up or down. And then apply your reflections to the positives and the negatives. Apply your positives and negatives. What am I talking about? People keep coming to my door distracting me. I'm sorry. Apply your transformations to the other points. Your 1, 1, 3, 1, 5, 1 deal. That's the easiest way to do this. So for this one, my first thing I see coming off the bat here, it's a negative in front of everything here. So this is going to be a y-axis reflection. Y-axis reflection. That means now it's going to be an upside down parabola because the leading term is negative. Now this is outside of this x, right? Do you see this here? This is outside of what the square is affecting. The square is affecting just the x itself. Since it's outside, it's a vertical shrink. Automatically, I know it. It's a vertical shrink. Shrink because it's 1/2. We're dividing by 2. And then it's up 5. So this one's got a lot going on with it. Start with 0, 0. The reflection, the shrinking, it doesn't affect 0, 0, so let's just go up 1, 2, 3, 4, 5. There's my new point. That's my new vertex. Now it's a y-axis reflection, so instead of going up 1 over 1, I'm going to go down. Now I'm shrinking vertically by 1/2. So instead of going down 1 over 1, I'm going to go down 1/2 over 1. Let me get in there a little bit deeper so you can see what's happening here. And then instead of going down 3, 1, 2, 3, I'm going to go down 1/2 of that. Just 1 1/2. So here's 1 1/2 over 1. And then instead of going 5, I'll go down 2 1/2. 1, 2 1/2 over 1. See how that works? And then once you get that side, you can just come over and copy the other side. Just like that. And don't worry, we'll do plenty more examples when we get into the class. All right? This is just to kind of get your foot in the door here. Ooh, that didn't focus very well, did it? There we go. All right. So what this next part wants us to do here is to write the equation of the following functions. Ooh, more announcements.
Justin Carrera, please come to the front
Justin,
office.
you're needed.
Justin Carrera, please come to the front office.
Carrera, because saying, never mind. Sorry. First, this thing started at 0, 0. It started with the parent function. We always start, in case you haven't noticed, we always start with this guy. We always start with the parent function. So it started here. How did it get from here to here? Well, it went left 1, 2, 3. Left 3, and it went down 6. So if I wanted to write an equation for that, I know I'm going to have a y equals. I know I'm going to have left 3 is a plus 3 squared. It's inside of the parentheses, moves it left or right. Minus 6 outside the parentheses, moves it up or down. And the second thing I have to answer is, did the size change? It's positive, it's going up, so I don't have to worry about a positive or a negative right here. So let's look at the size. Does it apply the 1, 1, 3, 1, 5, 1 rule? Up 1 over 1, up 1, 2, 3 over 1, up 1, 2, 3, 4, 5 over 1. It does, so nothing has changed. Pop an X in. All right? That's all there is to it. And if you graph this, you'll actually come up with this. And I would like you to graph this on your calculator, see if you come up with that. That's always an excellent way to check your work. All right, so let's write this down on number 6. This one is a little bit of everything. The first thing that popped out to me is it's a y-axis reflection. That means I'm going to have a negative in front of everything. All right, the next thing, it was right here. So I'm going right, let's see, I'm going up 8 and right 2. That gets me from 0, 0 to 2, 8, where it is now, where my new vertex is. And then something is happening here. Let's see what this is, what's going on here. Obviously, it's much wider than it was, right? It's much wider than it was. So let's see what's happening here. I'm going to find a couple of really good points. Here's my first one. And these have to fit perfectly, all right? They've got to fit perfectly. So let's see if we can find some good points. Looks like here's another good one. And then that doesn't quite fit perfectly right there. And I mean, when I say perfect, I mean you have got to be picky when you pick points. Because whatever pattern I come up with right here has got to fit the pattern for the rest of them. So let's see. Obviously, it's getting much fatter, right? So I'm going to call this a horizontal stretch. Let's see what happens. I'm going down 1 over 2, down 1, 2, 3 over 2, down 1, 2, 3, 4, 5 over 2. So notice between these points, my vertical hasn't changed very much between these nice, good points. But my horizontal has. I'm twice as big now. So let's see what this will do here. We've got y is equal to a horizontal stretch. Horizontal stretches are going to look like this. Parentheses, 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 parentheses. I went right 2, x minus 2, parentheses, parentheses, squared, up 8. It's a system to it. That's all it is a system. And then I need to figure out what goes in right here. I need to figure out I can go ahead and do my y-axis reflection as a negative out here. I need to go ahead and pick up what happens right in here. So my horizontal stretch. Horizontally, I'm stretching this thing. I was going over just 1 in the parent. Now I'm going over 2. I was going over 1, now I'm going over 2. I was going over 1, now I'm going over 2. So everything's twice as big. So how do you show twice as big when it's inside the parentheses? How do you show a horizontal stretch by 2, like this one is, when it's inside the parentheses? If you want to multiply your x's by 2, you always do the opposite because it's inside the parentheses, just like number 3. So I'm going to come down here and I'm going to say that this is 1/2. Now, there are obviously a couple of different approaches to this. The one that I've showed you here with counting off the 1, 1, 3, 1, 5, 1 is the easiest. It's the easiest to pick up on, but obviously it takes a little bit of practice. That's what we have class for. All right? Have a fantastic one.